What's up, my Rust homies, and welcome to another video. Today we are talking about structs. Every developer, even at the beginning, will encounter at some point some type of object-oriented programming, independently of the language of choice. If you come from Java or Python, those two are heavily object-oriented, especially the first one. As the name suggests, object-oriented programming, or OOP, revolves around the concepts of objects and classes. We can think of classes as the blueprints for creating several objects of the same class. For example, we can have a person class and two objects which are the concretization of this person class. So, the first one is Alice and the second one is Bob. The objects typically have some properties, like name, age, sex, and some internal functions that describe how the object and its properties interact with the outside world. In Rust, classes are not implemented per se. Instead, the closest thing we have are the so-called structs, which define only a group of properties, like name, age, and sex. So, they don't have internal functions, which in OOP slang are called methods. But actually, this is not entirely true, and we will see why in the next videos. So, why should you use structs? Why is always the most important questions one can ask himself, especially when learning new things. To put it simply, structs let you group multiple properties that make up a semantic group, and what's important is that you can actually give names to these properties. This can sound overwhelming if you're not used to reason in an OOP style, but now let's see some concrete examples to understand better. So, let's say we have a blog and we have a mechanism of user authentication. So, for us, a user will be an entity, hopefully human, that have the following properties: a username, an email, whether the user is currently active or not, and the number of times the user has signed in. So, let's translate these into variables. So, we have a user which has username Alice, then we have the email alice@example.com. The user is active and it has a count of 5 sign-ins. So this is pretty nice, and we can display its information like this. So if is active, then we print this to standard output. User email and then user has sign-ins. And here we will have the username, the email, and the sign-in count. Okay, let's just run this. Okay, so user Alice, then we have the email, user has 5 sign-ins. Okay, that's cool. If we have a second user, we can basically do the same thing. But now we have to change name to our variables, otherwise we are shadowing the information of Alice. So let username 2, email 2 is active 2, and so on. Now we can still copy this block. And we print the information relative to Bob. Okay, nice. So you can see that this actually works, but it's not scaling really well. Because what happens when you have 10 users or 100 users? So there must be another way to work. So, using loose variables is a messy way of working. We don't like that. So we can search for another way of grouping properties together. So maybe we can start with a tuple. So now we are enclosing all the properties relative to Alice in a single tuple. And then we can print this to the standard output all in one go. So user information. And then we print the tuple in debug mode. And here we have all the user information. And we can do the same thing for Bob. Okay, this is definitely more compact, but now if we want to access a single property, we have to use indexing, double indexing. So if we want to print the email, for example, so email of user, we have to access the index, so u1.1. And then we have email of user alice@example.com. So this is better than before, but what if we are working with an object that has 100 properties? We cannot remember all the indexes relative to that, right? So there must be a better way to do stuff. This is where structs come to the rescue. First, let's define the syntax. So this is the syntax for creating a new struct. We have the keyword struct, then the name of the struct, and then all the properties and the type of the properties. So for example, username, and then semicolon and string. So all these properties are described in a key value style. And then if we want to instantiate an object, we have to do this. So let u, like the assignment of a variable, then we have user, curly brackets, and then we give values to all these properties. So username, string from Bob, and so on and so forth. So this is how we create new users, and the struct user will be our blueprint for all the users that we're gonna create. And the action of creating a new user from the blueprint is called instantiation. So u is an instance of the user struct, and as you can see, the properties, as I said before, are defined as key value pairs, and the order of the properties doesn't have to be the same of the one in the definition of our blueprint. Okay, this is all nice and shit, but how can we access the values inside? The answer is by using dot notation. So we can do something like this if we want to print the username. So name will be u.username, and then we can print it. So let's just run this. And of course here we have username Bob. And don't worry about these warnings because we are not using these fields now, but this is how you access properties inside an object. Of course, if you want to print all the information relative to the user, we have to do something like when we were using loose variables, and this is not really comfortable. So how can we print a struct in a one-shot way? Going with the gut, we could do something like this. So user, and then we just print u, but this will actually not compile. Because user doesn't implement the display trait. So this is why we have this error. So if you want to print the struct all in one way just like that, the struct must implement the display trait. If you don't know what I'm talking about, you can see my video on traits to understand what traits are. But in general, a quick way to work around this is to implement the debug trait on the go. So we can just add this declaration here above the definition of the struct. So we have this rule. Oh, sorry. Use the derive keyword and then the trait we want to implement, which in this case is debug. So this will assign automatically the debug trait to the structs, and we can print it in debug mode like this, so semicolon and then the question mark. And now this will compile. Oh, of course, here we have a borrow error, but we are not interested in this anymore. Okay, now it should be okay. As you can see here, we have the debug display. So we have the struct, and then in curly brackets, the key and the value. Okay, that's nice. Now we know how to create structs and how to use them to create new objects. But since we are Rust fanboys, we know that the compiler is really strict when it comes to memory and its owners, and also immutability. So what do you think the situation is for structs? Are they mutable or immutable? Well, judging from the error that I got before, I hope that you guessed it. Guys, structs are immutable bindings by default. So let's try to manually change the value of a prop and let's see what happens. So if I write something like this, u.signinCount, so I want to change this to 10 for example, this will result in an error. And the error says that we cannot assign a value to signinCount property because u is not declared as mutable. And as you can see here, the compiler is talking about the struct as a whole. It's talking about u, not the property u.signinCount. And this is the help that it gives. So we can write the struct as mutable. And so this tells you that we cannot declare some properties as mutable and some properties as immutable. A struct is either mutable or immutable as a whole. Okay, this was a basic introduction of structs, and we could go on and on and on about them. But since I have a high opinion of my Rustacean community, let's talk a bit about ownership in structs. Because things can get really messy when we store some properties as references to other data, like for example a string slice instead of a string. So let's try to do this. So let's try to change a property to accept a string slice instead of a string, so in this case the email. And then we will build our user like this. So let's user, and then we have the username, which is still a string, and then the email a string slice. Now if we want to debug this, we can do the same thing as before, so a user, and then we reprint the struct in debug mode, and you will see that this will not compile. And here the error is pretty strange because it's telling us that we are missing a lifetime specifier. So you could ask ourselves, what are lifetimes? If you don't know, well, stay tuned because I will address lifetimes in another video. So, homies, thank you for watching and see you on the next one.